Hello, welcome to Understanding Computational Problems and Algorithms with Java. I hope you've gone through all the introductory video that I have produced for free to encourage you and to allow you to build the expectation that you will have from this course. I know, there are many courses out there that people come up with without actually allowing you to actually have a freedom to build that expectation. So that is the reason why I decided to come up with a free video to explain what all this course is all about. So this is the the third part of the course. The first one, as I have discussed in my video, it may not be directly linked to the course because the topics are really defined in a different way. But when you search for understanding of computational problems by research, it will link you to the second part of the course in the previous video, or understanding of the world computational problems that will also link you to the same thing. I also did something concerning IT and information tech, computer science. So when you go to understanding of the computer science and information technology, that will also give you the details concerning that course. So this is now the third part of the course. It's about understanding the real computational problems and algorithm with Java. The reason for doing this course is very simple. I came up with a model for the contextual and conceptual understanding of the world computational problems with Java. And that will also allow us to understand algorithm as well. So I just want to go through this video quickly to give you the topics that we will cover in this course. The first one will be just the introduction to the birth of science and technology and the computational problems, because we cannot do anything without history or without knowing the background. So I just want to take you back to the background so that we understand where just to have some kind of idea, and perhaps you may do further research to dig down more in order to understand what I am going to discuss with you here concerning the birth of science. I may not be absolutely right, or I may not give you all the details because this course is just an abstraction of the details, but with the core functionality of um, the elements that I need you to understand in order to understand anything concerning computing and computation. So the first part of this, the first topic is going to be just the introduction to the birth of science and technology and the computational problem. The second topic is going to be about the algorithm and the model for solving computational problem. Here we are going to go through different, not really like complex way of designing algorithm, but a way of we are going to show you a way of understanding algorithm. As I said before, this course is about understanding the context rather than concept and practice, because we want to find a way of putting ourselves at a certain angle so that we can be able to, to see the skill sets that we have and match it with the problems that are there in order to solve them. So that is the reason why we are going to look at the algorithm and the model for solving computational problems in the second course. The third part of this course is going to be about building a linear model for solving computational problem. My friend, that is the actual model I'm talking about. Is going to be a linear model. And this linear model is just one of its kind. There are many models out there, but I came up with this linear model so that we can easily understand how to solve computational problem and then build up the complex model from there. But at least we will know where to start from. The fourth part of this course which is the topic number 4, is going to be about the practical observation and application of this model. We are going to observe whether this model really, is really true, or perhaps whether it will be applied practically. We just want to understand it more. So we will have some kind of observation with some examples. Of course, the examples are going to be local and simple so that we can understand how this model works. The fourth part is going to be about the understanding of knowledge and algorithm. Knowledge or algorithm. You will appreciate this section because having knowledge alone is not enough, but putting that knowledge into practice will actually contribute a lot. So we need to know the best of the both worlds. You need to have the knowledge and use it. And we are going to relate this to algorithm and how to solve the computational problem. We are also going to take a look at humans versus algorithms. Because when we talk about algorithms, some people would think like maybe algorithms came from somewhere. So we want to see whether there's a link between algorithm and human being and the computer system. What is it? What is the common ground that they have? And we're going to look at how to build an algorithm. And as we know, algorithm is just a program or a computer system. And when we go deep to a computer system, then we come with a step-by-step way of solving problems. And that will give us the best explanation of algorithm. And it's almost like the second last part of the course is going to be about understanding what computer is all about. This is where now we are going to apply the knowledge we have gained, the concept that we have learned about algorithm to actually build a digital computer system. Then we will see how does a computer do the task. How does it do the task? What we give it to do? What does it? What happens when we give something to a computer to do? So this section of the course will actually explain this to us. Right. In the next video, we are going to start by looking at the introduction to the birth of science and technology. Welcome once again. My name is Samuel Ambrosonen, a BSc and MSc holder of Advanced Computer Science, specializing in artificial intelligence. I am also a reader of mathematics and computer science from one of the most prestigious universities in the world. I'll see you in the next video. We are going to start right from here. Thank you for viewing.